Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Numeracy series and concerns powers of 10 and standard form. This guide gives an introduction to powers of 10. It shows how powers of 10 are useful in describing large and small numbers. This shorthand is commonly called standard form. Powers of 10. Positive powers of 10. Multiplying the number 10 by itself a certain number of times always results in numbers which begin with 1 and are followed by zeros. For example, 10,000. In mathematics, there's a shorthand way of representing multiplication of a number by itself, known as a power or index. The number 10 is a good place to start learning how powers work, as the numbers produced when multiplying 10 by itself are easy to calculate. Start with the number 10 and multiply it by itself. 10 multiplied by 10 equals 100. Now multiply 100 by 10. Can you see that this is the same as 10 multiplied by 10 multiplied by 10? So 10 multiplied by 10 multiplied by 10 equals 100 multiplied by 10, which equals 1000. There is a pattern emerging. Every time you multiply by 10 in this way, you write an extra 0 at the end of the number. If you do this 6 times, you get 1,000,000. 10 multiplied by 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 10 equals 1,000,000. This would get tedious as the numbers get bigger and bigger. There is a shorthand way of writing these large numbers. A superscript to the right of a number, in this case 10, is used to indicate how many times that number has been multiplied by itself. Using the example of 1,000,000, you have multiplied 10 by itself 6 times, which can be written using the shorthand as 10 multiplied by 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 10, which can be written as 10 with a superscript of 6. In mathematics, this is referred to as a power of 10 and is said 10 to the power 6. A simple way of working out the power of 10, represented by a number beginning with 1 and followed by zeros, is to count the number of zeros. In other words, the number of zeros is equal to the number of times 10 is multiplied by itself. So 100 equals 10 to the power 2, as 100 is 1 followed by 2 zeros. 1000 equals 10 to the power 3, and so on. Importantly, 10 to the power 1 equals 10, and 10 to the power 0 equals 1. For example, express the number 100,000,000 as a power of 10. 100,000,000 is 1 followed by 8 zeros. This is 10 to the power 8 expressed as a power of 10, which represents 10 multiplied by itself 8 times. Negative powers of 10. Powers of 10 which are negative numbers also have a useful meaning. They represent proper fractions with the numerator of 1 and a denominator of the corresponding positive power of 10. In other words, multiplying by a negative power of 10 is the same as dividing by the corresponding positive power of 10. Mathematically, this can be written as multiplying by 10 to the power minus n equals dividing by 10 to the power n. For example, what fraction and decimal number does 10 to the power minus 6 represent? To represent 10 to the power minus 6 as a fraction, you use the rule above with n equals 6. So 10 to the power minus 6 equals 1 times 10 to the power minus 6, which equals 1 divided by 10 to the 6, where we have replaced multiplying by 10 to the minus 6 with dividing by 10 to the power 6. Continuing on, this can be written as 1 over 10 to the power 6, which equals 1 over 1 million, which is 1 millionth. 1 millionth is 0.000001 expressed as a decimal number. You can also find the decimal equivalent of a negative power of 10 by writing the positive power of 10 backwards and putting a decimal point after the first zero. Numbers in standard form. In disciplines which use mathematics as a foundation, for example science and economics, you may come across very large and very small numbers. For example, the distance across a galaxy is very large and the distance across an atom is very small. It takes many digits to write a very large or a very small number. This can lead to human error when writing or keying in such numbers. Every number can be written as a number between 1 and 10 multiplied by a power of 10. When you write a number in this way, you're expressing it in standard form. Mathematically, for a number to be in standard form, it must fit the pattern a multiplied by 10 to the power n, where a is bigger than or equal to 1 but less than 10, and n is an integer, a positive or negative whole number or 0. You can work out the general size of a number in standard form by looking at the value of n. If n is a positive integer, the number in standard form is bigger than or equal to 10. If n is a negative integer, the number in standard form is between 0 and 1. If n is 0, the number in standard form is bigger than or equal to 1 and less than 10. In order to convert a number to standard form, you need to separate the number into two parts which are then multiplied together. Part 1. The calculation of a. The first part to find is a number between 1 and 10. To do this, put a decimal point in the number after the first non-zero digit, working from left to right. This will always give a valid value for a. Part 2. The calculation of n. You can calculate n by working out the power of 10 required, which, when multiplied by a, gives your original number. For example, write 1456 in standard form. Part 1. Put a decimal point after the first digit in 1456 to give 1.456. This is a. Part 2. Now you need to deduce the correct power of 10. At the moment you have 1.456 multiplied by some power of 10 equals 1456. Can you see that you have to multiply by 1000 to make the mathematics correct? So 1.456 multiplied by 1000 equals 1456. As 1000 is 10 to the power of 3, n is 3, and you have 1456 equals 1.456 times 10 to the power 3, which is in standard form. Let's look at another example. Write 0.0235 in standard form. Part 1. First position the decimal point after the first non-zero digit, working from left to right, to find a. This gives 2.35. Part 2. At the moment you have 2.35 multiplied by some power of 10 equals 0.0235. It would be more obvious to divide 2.35 by a power of 10, specifically 100, to make 0.0235. As 100 is equal to 10 to the power 2, and dividing by 10 to the power 2 is identical to multiplying by 10 to the power minus 2, n is minus 2. Therefore you have 0.0235 equals 2.35 divided by 10 to the power 2, which equals 2.35 times 10 to the power minus 2, which shows that 0.0235 is 2.35 times 10 to the power minus 2 in standard form. Further guidance and information. If you have any further questions about numeracy or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a Learning Enhancement tutor in the Dean of Students office. You can telephone 01603 592 761 or email dos.help@uea.ac.uk or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.